Now, some of you probably had geometry in high school. A little bit of there's a course after Algebra 1 you take geometry. Hopefully you took that course. You know some of the stuff we're going to be talking about. We don't teach geometry here. There is no course for geometry. If you decide I want to learn about geometry, we do not have a class. We have pieces in each course. So in this chapter we have a little bit actually of geometry, color sections, and that's it. So we are going to talk about a couple of things. One, angles. Now, I might have a protractor here. Let me see if I have one. Yep. Perfect. I do have a protractor here. When you measure angles, for those people who never, here we go. Let's say I have this angle, and I go, how big that angle? What's this angle equal to? What is that equal to? I'll take my protractor, and here's one. And the center where they line up, there's the 0. And I don't know if you can see it or not. You can see that line is a little bit before 50 degrees. See it? It looks like about what, 47 maybe? 46, 47 degrees. So that angle is called, 46, 47 degree angle. If we measure the angle in this direction, we use positive angle. If we measure the angle in the reverse direction, we use negative angles. So if I draw another one, and let's say this is my angle now. There we go. And I say how big this angle. Once you lay this upside down, the angle is measured as negative value. So when you look at this, this is the 90 degrees, negative 90 here. So you have more than 90 degrees. Keep going. Notice there's two scales on that. This is 130, and that's the 135. So it looks like approximately 135. So we say that angle is negative 135 degrees. The negative indicate you went in this direction to measure it. If you want to measure it this way, we said, okay, what is that value? That way. The whole thing, if you go around what? 360. So what's 360 minus the 135? That's your angle. Or to go from this line to this line, you have 180 degrees. So you can measure that opening and you figure out what the value. But the easiest thing is 360 minus 135. And that will tell us what that angle has a positive value. So the angle can have two values. One could be positive, one could be negative. It's the same angle. It depends which direction you go and you measure them. Now, when you have a straight line, the angle between them is what? How many degrees? If I give you this one again, let me draw this one. And I label this point X, this point is Y, and this point is Z. What our book will say, give me the angle. This is how we ask for the angle. The angle of X, Y, and Z. The angle between X, Y, and Z. So again, I take my protractor, and I measure that, and I go, that angle looks like about maybe 37. That's 37 degrees. Or you might have a line that looks like this. And I'll call this point A, B, and C. And I go, what is the angle between A, B, and C? What's that angle? To go from A through B to C, look at your angle. What does the protractor say? How big that angle? That's 170, that's 180. So straight lines equal what? 180 degrees. Not 0. 0 means go back. Come this way and go back. That's a 0 degree. But to go all the way around, that's 180. To go straight up in the air, that's 90 degrees. Now you're going to hear about acute angles. There we go. Two angles are complementary and supplementary. Let's talk about them here. Two angles are complementary if what? Anyone? Complementary if the sum of them equals what? Equals 90 degrees. Two angles are supplementary I missed the A. Are supplementary if the sum of the angles is equal to what? 180 degrees. One more thing I forgot to mention, you probably know it. If you add all the angles in any triangle, what's the sum? Always 180 degrees. So if I have a right triangle, the word right triangle, what does right means? Which is how many degrees? 90 degrees. So when you have a right triangle, this is you have a 90-degree angle. Those two angles, I'll call them alpha and beta, x and y, whatever you want to call them. We use Greek letters A, B. We use alpha and beta because most of the trig was discovered by a Greek mathematician. To show like appreciation to them, we use Greek letters. Those two angles, when you add them, they have to add up to what? 90 degrees. Why? Because the sum of all the angles, alpha plus the 90 degrees plus beta, have to equal 180 degrees. All the angles of the triangle, they add up to 180. So what is alpha plus beta then equal to? 90 degrees. And if the two angles add up to 90 degrees, they are what? Complementary. So alpha and beta are complementary. Because their sum adds up to 90 degrees. On the other hand, I'll wait. I've been up since 3:30. I drove my son to the airport at 4 o'clock in the morning. So I'm ready to go. Let's look at supplementary angles. Let's look at these two angles, alpha and beta. Alpha plus beta here, they have to add up to what? That's 180 degrees straight line. 180 degrees. So those two angles are what? Supplementary. Because their sum adds up to 180 degrees. So that's when you hear with complementary versus supplementary. A little more terminology you're going to hear. Intersecting lines. I'll put that on next page. Clean sheet. What's intersecting lines? From the name, they cross each other, right? They don't have to cross at 90 degrees. They could cross like this. That's not a 90 degree. Those are what intersecting lines are. They cross each other. They could cross at 90 degrees, but they don't have to. They intersect. They cross each other at one point. Parallel lines. What do we know about parallel lines? They never touch. Exactly. The distance between them is the same. They don't intersect. Those are parallel lines. There is no intersect. They never touch. The distance between them is the same. I just realized it's hard to see these colors. There we go. Is that better? And the last one, we're going to talk about perpendicular lines. Well, perpendicular lines are intersecting lines, but there's a special case about them. They intersect at 90 degrees. That's what perpendicular lines are. When they intersect at 90 degrees. So you're going to hear these terminology in trig there. Parallel lines, intersecting line, perpendicular lines. Perpendicular is actually intersecting lines, but intersect in a special way. They make a 90-degree angle. When you come to an intersection, a lot of times you have one going this way, one going that way at 90 degrees. Those are perpendicular lines. But if they make something like this, it's not perpendicular, it's just intersecting lines. So if we take one like this, and if I said to you this angle is 50 degrees, let's go back to that one. Can you find what this angle is, what that angle, and what this angle is? How? How did somebody say yes?
You take 50, or you do 360 minus 50, or 180.
Well, which one are you trying to find? Let's call this one alpha, so give them a name. Let's call this one beta. And gamma, God knows how to make gamma, or zeta. I'll use zeta. I don't know, looks lumps. There we go. Greek letters. I could call them X, Y, and Z, make life easy on me. Where's my eraser? I don't have an eraser. Are you trying to find alpha?
Yeah. So
If
you do 180 minus 50.
Correct. Because if you remember, this line here makes 180 degrees. If you know that's 50, then alpha is going to be 180 minus the 50 degrees, which is what? 130. It has to be. What about beta? These two angles, when you cross line like this has to equal to this, and this has to equal to this. So what is beta equal to? 50 degrees. What is zeta equal to? 130 degrees. So once you know one, you know this. Once you have this, you know this, you know this, you know that. So you can find them all once one of them is given. In this case, if this is 90, what's this angle? 90, 90, 90. Equal values. So what kind of questions they might give you? Because they're not going to ask you if you know the definition of complementary or supplementary. You might see a question that looks like this. Angle A, that's how they write that, angle A, and angle B are complementary. Complementary angles. Okay, I'll put angles here. Now, angle B equals 69. What is angle A? A lot of times you see the word M in the front of this. That means the measure of angle B. When you measure angle B is 69 degrees. So if you were to measure angle A, what are you going to have? Well, since they're complementary, what's the sum has to be? 90. So the measure of B plus the measure of A, if you measure these angles, they have to add up to 90 degrees. Well, we know this one is 69, so can we figure out what that one? Isn't that equal to 21, is it? So those are the type of the question. If you were to measure angle B is 69, if you were to measure angle A, what would it be? And we use the definition of complementary, which means the sum adds up to 90 degrees. You might see the same thing with supplementary. This is two angles are supplementary. One of them 85 degrees. What's the other one, you know? Same thing. Another question you might see is they might give you a problem like this. Oh, come back here. Just making sure you understand angles. Let's say we have an angle like this. This angle is 50 degrees. This angle here is 108 degrees. I'm making things up. Can you tell me what this angle, x? What is x equal to? Any idea? What is it?
108.
Well, 108 from here to here. From this line to this line. That's what you see that line here? That says the 108 from here to here. The 50 from here to there. I need to find what that angle. Yep, because if you take the 50, add to it x. If you take this angle to go from here to there, add to it from here to there, it should equal the angle from here to there, which is what? 108. So to get x, what do? Subtract 50. Is that 58 degrees? So 50 plus 58 will make it 108. So 108, notice why I drew the blue line. The 108 is this angle. From the ground, from this line, that's your reference. From the reference to that line. That's usually called the initial side. That's called the terminal side, we call them, where we end at. That's your terminal side for the bigger one. Reference, initial side, that's your terminal side for the little one. So it's the difference between the two angles. That's what x is. Now, we're also going to be looking in this section, beside angles, we're going to be looking at shapes. And I have a handout I gave you last class. Where's my handout? Let me take a picture of it. I have another one somewhere here. We are going to be looking at these shapes. Right now, I'm only interested in angles. So this shape is called trapezoid. What do you notice about the trapezoid? Two sides are parallel to each other. This one is parallel to that. These two don't have to be. This shape is called rectangular shape. This side is parallel to this. This side is parallel to that. The other thing you notice about rectangular shape, the sides are not equal. Notice A in this picture is bigger than B. Another thing, the angle's always what? 90 degrees. I don't have one here, but we have a square. A square is similar to a rectangular shape with the difference what? The sides are equal, exactly. So A and B will be equal. So it's a special case of this one. This is parallel to this is parallel to this, and the angle for all of them is 90 degrees. Parallelogram, the angles don't have to be 90 degrees. They could be. One of them could be. This also, trapezoid, not parallel. This is a trapezoid. This is parallel to this. This angle is 90, this is 90, but these two are not. But this side is parallel to this. Now this is called parallelogram. It's like taking a rectangular shape and push on it a little bit there, dent it. And if you bend it, this side is parallel to this side is parallel to that. The angles are not 90 degrees. So these are some of the shapes we're going to be looking at in this chapter. We're going to tell you how to calculate the area for them, how to calculate the perimeter for them. We have these equations, and we'll look at them when we get to them. So our book actually talks about them here. A trapezoid. It says one pair with one pair of opposite sides parallel. One pair. So this is parallel to that. Could be these two, but this is parallel to that. Notice what it says here, if you can see it. The side A, B parallel. We use the lines up and down to write parallel to B, C, and D. Parallelogram. This one parallel to this, and this one parallel to that. Rectangular, the angle's all 90 degrees. This side is parallel to this side is parallel to that. The lengths are not equal. The square, very similar to that. The sides are equal. This is parallel to this is parallel to that one. If you add all angles in this shape, any one of them here, the sum always going to be what? 360 degrees. What's 90 plus 90 plus 90 plus 90? 360. 90, 90, 90, 90, 360. This, and that, 360. This, and that, 360. So the sum of the angles always have to be 360 degrees. The reason, by the way, the sum is 360, in case you're wondering, are you sure the sum is 360? Watch what will happen. If I connect the line here, what do you have? Don't you have two triangles? There's one triangle, there's another one. What's the sum of the angles in any triangle? 180? 180? What do you have? 360. If I draw a line between any 2 points, doesn't matter what 2 points, I'll have two triangles. When you add the angles, 180 plus 180, which is what? 360. That's why these sides always have a sum of angles equals 360. That's the reason behind it. It's actually two triangles into one. Circles, we'll get to circles too. This point in the middle is called the center. The distance from one edge to the other edge going through the center is called the diameter. And the distance from the center to the edge is called the radius. So when you look at the picture, the radius is half the diameter, or the diameter twice the radius. diameter here, the A to B, is twice the distance from O to B. So there's the terminology from section, what is this section? Section 1, whatever, 11.1. You might be given a problem like this, just the last one. This angle is 90 degrees. This is not. It looks like 90, but just a hair more than 90. This is 95 degrees. This is 60 degrees. And the question, can you find this angle? We'll call it angle D. What is angle D? If you measure that, what's that angle should be? We know when you take these four angles and you add them, the sum should be equal to what? 360. So if you take D, add to it the 60, add to it that angle. What's that angle, by the way? 90 degrees. They don't write 90, they just throw a square. Plus the 95 should add up to what? 360? 180? And 185 actually. Plus 60, is that 245, is it? And to solve for angle D, you subtract 245. So if you were to measure angle D, the value 5 from 10, which is 5, 4 from 5, 115 degrees. And you can see it's more than 90 degrees from the picture.